the dew point depends on the pressure. So when you are doing a specification when we are doing a specification, we need to relate to dew point, we need to inform the temperature and what is the pressure related to that. And based using the Einstein high C's, what I did a relationship between the dew point of the gas and with the dew point, what is the relation related to the mass available in this gas? So how many pounds has in minus 39 Celsius degree? And I did another curve showing to me what is the expected temperature to have the hydration formation. So just to clarify better to you, taking in account that I need minus 39 Celsius degree, and we are talking about this abscess here. Here I have minus 39. It means that at minus 39, if I use the light blue line, I have around 7 pounds of water per million cubic feet. And to have the formation of the hydrate, my gas must reach around between 0 and minus 5 Celsius degrees. So he is around minus 2.5 Celsius degree. So with that, I can evaluate how much I should reduce the water content in my stream. For instance, if I didn't worry about the regulation, but if I just wanted to have a safe temperature margin to don't have a hydrate formation, I could choose, for instance, the minus 34 Celsius degree dew point. Why? Because at minus 34 Celsius degree dew point, I would have formation of the hydrate at 5 Celsius degree, but as by history of my unit, by history of my operation, I always operates above 15, or the minimum temperature, operating temperature was 15 Celsius degree. I have 10 degrees of margin, and reducing the dew point to 34 should be enough in terms of operations. And that is very important because, of course, as much water content you must remove from your water, as much will be expensive the technology that we use.